In this lesson, we'll look at finding the maximum or minimum value of a quadratic function by completing the square. So we saw in the last lesson that there are three forms of a quadratic function. There's the vertex form, standard form, and factored form. So remember with the vertex form, the reason why it's called the vertex form is because by looking at the equation, you will immediately know where the vertex goes. The h and k values will tell you that. Now there's also the a value right here, which will vertically stretch, compress, or reflect your parabola. So if we want to find the maximum or minimum value, first of all we have to determine whether it is a maximum or minimum, but you can tell by looking at the a value. Remember, if a is greater than 0, this will result in the parabola going upwards, so that means your steps are going up, which means that the parabola will have a minimum value. The vertex would be the lowest point. If a is less than 0, so a negative number, that means the parabola will be going downwards, and the vertex would be the maximum value. Now, not only are we able to tell with the vertex form whether it's a maximum or a minimum, we also know what that maximum or minimum value will be, and that will be the y-coordinate of the vertex, or the k value. So if we have the vertex form, it's very easy to see whether it's maximum or minimum and then what the value is. However, we're not always going to have the vertex form. So let's say, for example, we have the standard form equation. We would like to put that now into the vertex form, and we're going to be doing that using a method called completing the square. Now, before we talk about how to complete the square, we should review what a perfect square trinomial is. Now, if you have a plus b, that's a binomial and it's squared. Remember, that means a plus b multiplied by itself, a plus b. Now, you can expand that using FOIL, but if you kind of know the shortcut, we know that it's going to expand to this, a squared plus 2ab plus b squared. So the way the pattern goes is the first term is the first term in your binomial squared, so a squared. The last term is the second term in the binomial squared, so b squared. The middle term right here is the first term times the second term and then times 2, so plus 2ab. So for example, I can say x plus 4 squared. I can immediately factor that into x is the first term squared, plus 4 is my second term, so I'll be finishing with 4 squared is 16. And in the middle, I want to multiply those two. X times 4 is 4x, but then also multiplying it by 2, so that'll be plus 8x. So that's an easy way of expanding it if you can remember this expansion right here. So what we want to do for completing the square is kind of go in the opposite direction. So if I give you x squared minus 6x plus 9, we want to be able to factor that into a perfect square. So here's the trick. Remember that the middle term right here is the first term times the second term times 2. So if we're going in the other direction, I want to divide that number by 2, and that will tell me what my second term is. So if I take negative 6 and divide it by 2, I know it will be minus 3. So let's take a look. Is x minus 3 squared really equal to this trinomial? So x squared, negative 3 squared is positive 9. So far so good. And then x times negative 3 times 2 is negative 6x. So that works. So again, the trick is to go from the standard form to a perfect square. You take the middle term, divide it by 2, and that is the term that goes in your binomial. Alright, so let's say that we're given the standard form equation, y equals 2x squared minus 12x plus 28. I want to find the minimum value of that, and we're going to complete the square. Now first, how do we know it's the minimum value? So this a value right here, the coefficient of x squared, it is positive, which means the parabola will be going upwards. So that means the vertex is at the minimum. Sometimes you'll have to determine yourself whether it's minimum or maximum. Now the first step is, in the vertex form, x should never have a coefficient. So the first thing I'm going to do is I'm going to factor out a 2. I'm going to factor out that coefficient, and I'm only going to factor the first two terms. So there's a reason for that that we'll see a little bit later on. So x squared minus 6x. Now I'm going to leave myself a big space here in my brackets, and the plus 28 is just going to kind of hang out here by itself. So the reason why that I'm not factoring this 28, the reason why it's called completing the square is that now we are going to figure out what number has to go right here in order for this to be a perfect square trinomial. So I like to kind of write on the side what trinomial or what binomial squared am I looking for. So if I have x squared minus 6x, remember the trick is to divide that number by 2, and that is minus 3. So I want it to look like x minus 3 squared by the end when I factor it. Now, to complete the square though, I have to have that last term added on. So remember, for a perfect square trinomial, it is this second term squared that we finish off with, so plus 9. So x squared minus 6x plus 9 is a perfect square trinomial. The problem is right now is you can't just add 9 to an equation or an expression because now it's different. So if I want a difference of 0, so meaning that there's no change to the equation, I can now subtract that number as well. Adding 9 and subtracting 9 is 0, so then I do not have any change to the equation. So now though, I don't actually want that minus 9 inside my brackets because that's not going to help me with factoring the perfect square. So I want this negative 9 actually on the outside. Now one thing to remember is that with this 2 out here, everything in the brackets really should be multiplied by 2. So if I want to bring that minus 9 on the outside, so I have just my perfect square trinomial, that will be negative 9 times 2, times the coefficient in front of the brackets. So that will become a minus 18. And then we have plus 28 there as well from before. Okay, so that negative 9 becomes the negative 18 because it's been multiplied by 2. Now at this point, I know that x squared minus 6x plus 9 factors into x minus 3 squared. And then I can combine these two right here. Negative 18 plus 28 is plus 10. So what this tells me, because this a value is positive, I know it's going to be a minimum value. It's a minimum of, and this right here is the y coordinate of the vertex, remember. So a minimum of y equals 10. And what I also like to see added in is when x equals, so what's the x coordinate of that vertex? That would be positive 3. So that's our final answer. So we have our vertex form, but we also have to state whether it's a minimum or maximum, what that value is, and when it occurs.